Hello, mathematicians. So we are on page 8 of our Unit 6 packet, Day 4, Simplifying Radicals. Actually, one of my favorite lessons. Today we're going to be simplifying radicals using prime factorization. I'm just going to write that down. So some words that are familiar to us, the word prime, right? So that we're talking about a number that is a prime number, and in our definition of prime numbers, it is numbers that are only have factors of 1 in itself. So some examples would be 1, 2, 3, 5, 7. Okay? And something we're also familiar with the word factor. Okay, so we're actually looking at factors used as a noun here. Okay, going back to our definitions of the word factor. So let's look over in the first box where it's saying simplify the following radicals, and the first one is radical 40. So I'm also going to be referring to the video that is posted in our Google Classroom under calculator tips and tricks. It's the one on finding the factors of a number using your calculator in the y equals feature. So when I'm talking about finding the factors using the calculator, you could just pause this video and look at the calculator video. If you want to take a look at that before you actually start this, that's fine as well. So when I'm looking at this, I am putting 40 in my calculator. I'm looking at the factors, and I'm going to just work with something that I'm familiar with. So I'm familiar with the numbers 4 and 10. Those are both factors of 40. But then what I want to do is that I want to keep breaking it down until I get to prime numbers. So if I broke down 4 even further, I could say 2 times 2. And I know that 2 is a prime number and 2 is a prime number here, so I'm going to stop. And I'm going to indicate my stopping by putting a line under the number. I'm going to go to 10, do the same thing. So 2 numbers that multiply to 10, 5, and 2. And again, I know that 5 is a prime number and 2 is a prime number. What I then want to do here is actually put all these numbers back in. Now before I do that, if I were to put the multiplication operation, okay, which is a dot in this case, with all these prime numbers, if I were to multiply them together, and I could use my calculator for this, I will notice that 2 times 2 times 5 times 2 is going to give me 40. Okay? So if I'm looking at radical 40, I actually could put all that back in. So I put that all back into my radical. So 2 times 2. I'm just going to put it in number order. Times 2 times 5. What I'm then looking to do is actually circle some pairs. So here's a pair right here. And then I could actually break this apart again and have radical 4, which is 2 times 2 times radical 10. 2 times 5, okay? I'm just going to arrow so you can see what we're talking about. And if I were to simplify this, well, with the square root of 4, is 2. And if I were to take the square root of 10, I would notice that I would get a decimal using my calculator. So I'm just going to leave it as radical 10. So going back to this, our original thing about simplifying the radical, if I were to simplify radical 40, I would get 2 radical 10. Okay? Let's look at this next one. So it's telling you simplify the radicals, radical 392. Definitely a big number, definitely something that I'm putting into my calculator. And when I do that again, I'm going to y equals. I'm going to use the fraction feature, alpha y equals enter. And on top, I'm going to put 392. And on the bottom, as my denominator, I'm putting x, because we're looking for the factors of 392. Again, we're looking for whole numbers. We're not working with any decimals or fractions. And I'm just going to pick two numbers that, again, a pair that I feel comfortable with. So I feel comfortable with breaking down 8 and 49. If I were to break down 8, I can then say 8 could go down to 4 and 2. And 4 could then be broken down to 2 and 2. I know that 2 is a prime, so I'm going to stop there. 49, I'm going to break down either further to 7 and 7. I know 7's a prime number, so I'm stopping there. Okay, again, essentially, if I were to put an operation of multiplication between all those prime numbers, 2 times 2 times 2 times 7 times 7, into my calculator, I'm going to get 392. So that being said, I could kind of plug all this back into my radical. And I would have, again, I want to put it in order, so I have 2 times 2 times 2 times 7 times 7. Okay, and I could pair 7 and 7. And I could actually pair it 2 and 2. So if I were to break this apart, I would have radical 2. And radical 2 times 2 would be 4. Times radical 7 times 7 would be 49. And if I were to simplify this, well, I know the square root of 4 is 2 times the square root of 49, which is 7. And I can't take the square root of 2 because that's going to give me a decimal, so I'm going to keep it, I'm going to keep it as a radical. Okay, and I could combine my like terms. So 2 times 7 would give me 14. I'm just going to bring this back up here. So in conclusion, I could say when I simplify radical 392, that would be equivalent to 14 radical 2. Okay, so there are a bunch of these for you to try out today, and that's it.